I'm Abdul Fatah. I'm going to present to you on my section D.
Okay, first off, definite integral fx dx a to b. We can integrate it to x by using the derivative in the formula book, page 17, the standard integrals, and then we use the exponential function and the trigonometric function to find the x. But however, some of these values may not be able to find in the formula book to find the standard integrals derivative. So therefore, we put in a curve. Okay. So we put in a curve, and label it y equals to fx, and fx a to b is the area. We find the area is the approximation of the final answer, but it will not be the final. The exact and final answer. It will just be the approximate of the final answer. To find this approximation, we have to use the either one of the two rules, trapezoidal rule or the Simpson's rule. Okay, first off, the trapezoidal rule. Trapezoidal rule. Okay, a trapezoidal rule uses trapezium and define a trapezium. Trapezium is this shape. This is the trapezium shape, and the trapezium has parallel sides and a perpendicular of a height. This height plus these two, this height times these two parallel sides times half is finding the area of the trapezium. So when we put on a curve and we join these lines to a straight line, we can define it as a trapezium, which is similar to this and this. So by finding the area of this trapezium is similar to this trapezium, which is half times a plus b times h. Okay. A trapezium, the trapezoidal rule, we can say that it has an even or odd subintervals. Okay. This is y0 to y7. Okay. It can be y0 to y6, which is even, and also y0 to y7, which is odd. And this represents one subinterval, and it has two data points. And this is what I said about the area of the trapezium. We can apply half times a plus b times h, which is further derived as h over 2 times a plus b. Okay, we move on to the Simpson's rule. The Simpson's rule is okay. It will have more than two subintervals. Okay, Simpson's rule. It uses 3 points, and given to calculate the area between the first and the third, the area between the first and the third, this area. Okay. To find it, we have to calculate using under the area of the parabola, which is ax squared bx plus c. So to find the area, we integrate it into minus h to h, integrate the ax squared plus bx plus c dx. So we can put it in, and we define it as h over 3 y0 plus 4 y1 plus y2. y0 is the first point, y1 is the second point, and y2 is the third point. So minus h to h. Since Simpson's rule uses parabola calculation, we have to do it 3 by 3. Okay, y0, y1, y2, y2, y3, y4, y4, y5, y6, y6, y7, and y8. It's a 3 by 3. We cannot do it oddly because when it reaches y7, it has to have another point, the third point. Okay, from here you can see that this is a parabola, which is y equals to ax squared plus bx plus c, and these 3 points minus h, 0 and h. This 3 point, it needs 3 data points for parabola. And when you put it ax squared plus bx plus c, which is the curve here, and when the x is represents by my h and 0 and minus h, it is equals to 2ah squared plus 6c.